Hello and welcome to the sex-linked traits, and I also have stuff about pedigrees and deciding how a trait is inherited via a pedigree. So the alternative to this lecture is to be watching two Amoeba Sisters videos, one about sex-linked traits and the other one about pedigrees. So if you're still not getting it after this lecture, I would maybe take a peek at those. But here we go. So remember that sex chromosomes determine whether the offspring is male or female. So if you take genetics with me, Miss Mueller, we'll learn that things are not so clear-cut or black and white, especially when it comes to chromosomes and male and female. But we all have a collection of chromosomes here, and we have certain numbers. So remember that we have 23 pairs right here. So 1, 2, 3, 4, 21, 22, and 23. So we're going to have different things found on different chromosomes, and depending on where they're found, things can have a different probability of how they're inherited, and I'll explain later what that means. So you have autosomes, and I'm sorry for this really blurry picture, but we have autosomes and we have sex chromosomes. So everything we've talked about up until this point, everything about Mendelian, complex traits, dihybrids, we assume that it's happening on one of these chromosomes. Okay, everyone and their mom has these. If you're a boy, if you're a girl, everybody has these. Depending on whether you're male or female, now here's where things might get a little bit hairy. So we have XY, and there's also going to be an XX individual. So XX, if you remember, is female. XY is going to be male. So that is going to be really the only difference chromosomally between males and females. So these sex chromosomes are going to be encoding for things like ovaries and sperm and penis and vagina and all that fun stuff. But it's also going to be having information for some other traits as well. For example, clotting factors. When you cut your skin, your blood clots and you form a scab. These genes that code for some of these proteins in our body are found on these chromosomes, specifically the X chromosome, as does the ability to distinguish between colors, specifically between red and green. That is also found in the X chromosome. And muscle function, and I'll tell you a little bit more about that later when we talk about diseases. The Y chromosome actually doesn't have a whole lot of genes on it. I learned in my grad school class that this guy has like 1,000 or maybe like 500 genes. This one has like 3,000 genes. Really the only thing that's on this bad boy is things for like sperm and like fertility and that type of junk. Whereas everybody has at least one X, so we have some other thingamajigs on that are going to be important and not just for like making babies. So remember that genotype for male is XY. You got your X from mom, and therefore you got your X from dad. So for female, you're going to be XX, meaning you got an X from mom and an X from dad. So I always like to tell a story about King Henry VIII. If you remember, he was in medieval times. He was like Bloody Mary and Queen Elizabeth's dad, and he had 6 wives. And he was kind of a big jerk because he liked to divorce, banish, or kill his wives. And part of the reason why is because he was mad that they weren't giving him any sons, because those were the only people that could really inherit the throne, and those were the preference back in the day. So he beheaded one wife, Anne Boleyn, pretty much specifically because she didn't have a boy. Look at this picture. Whose fault was it that they weren't having any boys? Was it the female? Or was it the sperm that determines the sex of the baby? It's the man. Okay, so gentlemen, if you have a sex preference, you decide what you get. Because ladies, we can only give X's. Okay, that's all we can give. And everyone and their mom has an X, so it's only the sperm that determines the gender of the baby. Or I should say, sex. So what's the probability of having a boy? Okay, so maybe take a minute, look at this Punnett square, and then I'll reveal the answer. So do it now. 50%. So every pregnancy has a 50% chance of being a boy. I'm a fan of trash TV, especially in the summertime. So there's nothing to watch on TV at noon on a Wednesday. So I watch a lot of Maury, and I remember that there are some fools on there that are like, I can't have girls, that child ain't mine. That's a lie. And you know why? This Punnett square proves it, okay? You have a 50-50 chance every time of having a boy. So just because you happen to have all girls That's totally fine, but it's 50-50 with every pregnancy. Okay. So there are some common sex-linked disorders that are found on those sex chromosomes, and one of which is muscular dystrophy, specifically Duchenne muscular dystrophy. And that has to do with your muscles. Often they're confined to a wheelchair, and it's really an awful disease. So do some more research. Color blindness, specifically red and green. So if you're at the grocery store and you're trying to pick out, the delicious Honey Crisp apples from the disgusting Granny Smith, you're going to have kind of a hard time. You're going to have to read your labels. Male pattern baldness is also linked to sex, and hemophilia. This is a picture of, what's his name? Nikolai, Anastasia's dad, if you've ever heard of the story Anastasia. Alexei, I believe that's this fool right here. He actually had hemophilia. So, these were the Romanovs. Nicholas Romanov. And if you watch the movie, the Disney movie, and history, the Bolsheviks killed them all. But yeah, he had hemophilia. So let's talk about some sex-linked traits. So those traits that I gave you, those genes for like clotting factors and color blindness, all that jazz, are found on the X chromosomes. So therefore, males and females are going to be affected differently. So who do you think would be more affected if there's a problem in the gene? Boys or girls? Think about it. Well, look at this picture. Okay? If I have a gene for seeing color and it's mutated and it's bad, it doesn't work. Do you see that gene anywhere on this chromosome? No. Why? Chromosomes don't really have anything in common with X's. They're actually really, really stubby and short, and as I said before, they only contain genes for like testicles and stuff. So boys, you got one shot. Okay, Eminem's actually talking about genetics. You got one shot. Do not miss your chance to blow. This opportunity comes once in a lifetime. Whereas ladies, you have these long, graceful X's. If this guy's bad, boom, you got a backup. Not the same for boys. Something bad over here, sucks a suck. Okay, my motto for this unit is boys are screwed. So yeah, boys are screwed. And girls have a backup. So how females are affected. If a female has one bad copy of a bad gene and one normal gene, she's considered a carrier. So if this one's bad, this one's going to be good. So she's not going to suffer from the disease, but she can definitely pass it on to her children. So it's kind of going to be hidden in her genes. If she has two bad genes, so if this one's bad and that one's bad, well, bad news bears. She will have the disease, so that's why it's pretty rare to have a colorblind female, but not entirely impossible. So here's how we express genotypes for sex-linked traits. It's really important that you put if they're a male or a female. So for females, I should see a butt ton of X's, and then I put this superscript to show the dominant and recessive. We're always going to assume that normal is dominant and diseased or abnormal is recessive. So in this case, if you have big, big, you're normal, big, little, you're normal, but you're a carrier, whether or not you know it. Little, little, you got hemophilia. So how boys are affected, they do not have a backup copy. Okay, see the stubby thing? It really has nothing in common with this one. So if I have a bad copy right here, boom, I don't have one. Sucks to suck. So males, again, it's really important that you write the sex in when you're talking about male sex-linked traits, and you never, ever, 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 never put anything on that Y. Again, this guy does not have a good gene. He doesn't have a bad gene. He doesn't have a gene flat out, period. So never put anything on the Y. Ever, ever, never. Ever. So let's do a practice problem, okay? We're going to cross a heterozygous female with a normal male. So because I'm doing a sex-linked trait, and I told you so, we will tell you if it's sex-linked or give you one of those characteristic diseases, you'd put some X's up here. So heterozygous female, big B, little b, aka a carrier, big B for the male, who's normal. If I do the Punnett square, I can find the ratios. It's cut off right here, so below this guy right here, it says half the males will be colorblind. So this is key. Again, as I said, never, ever, ever, never, ever put anything on the Y. Don't do it. don't. So again, only on the X. So for example, if my gene A is mutated, do you see a gene A here? Do you? Do you? You don't. That's why there's never anything on the Y. So let's do an example problem. Okay, a man who's hemophilic has a children with a carrier female. Give the genotype and phenotype ratios. Do this in your notes and call me over and I will check your work. I'm going to move on to pedigrees now, so pause it if you need it. I'm moving on. Let's talk about pedigrees. So you guys know from the pedigree Poggle that we have a bunch of X's and a bunch of O's, and it kind of looks like an upside down family tree. Well, your task is going to be to decide, is it inherited autosomally or is it inherited via sex-linked? So pedigrees are a tool, they're a model to help you determine how a disease is inherited. So autosomal diseases originate in mutations from non-sex chromosomes. So hair color, eye color, all those things are on an autosome. Chromosome numbers 1 through 22. An example of this disease would be Tay-Sachs. It's a really awful disease. Look it up. Sex-linked diseases occur on an X or a Y, more often the X because it has more genes, and they determine your gender, but they also have other stuff. Chromosome pair number 23, an example would be colorblindness, hemophilia, and baldness. So again, autosomes, sex chromosomes, sex-linked, autosomal. Oops, it's fine. So you know you're looking at an autosomal disease because both sexes are more or less equally affected. But the disease can also be dominant or recessive. So if it's dominant, if you have the disease, you're going to be homozygous dominant or heterozygous, because that would mean that the capital letter's the bad one. Recessive means that you only have it if you have 2 little letters. Oh, crap. Okay, it says heterozygous are carriers and can pass the genes on to offspring, but they don't have it themselves. It's hidden in their genes. It's no different than, my mom and my sister are redheads, so I'm probably a carrier for red hair. It's no different from that. It's hidden in my genes. I wish I have a redheaded baby. X-linked, on the other hand, you know you have it because males are more often affected. Go back like 4 minutes. I said like a million times how boys are screwed. Okay, they have one shot. And if they get a bad gene, sucks to suck. Females are only affected if they're homozygous for those 2 bad copies, which we're only going to give you recessive ones. But there are X-linked dominant ones, but don't worry about it. Females are carriers as well. You cannot have a male carrier. Why? Because you don't put anything on the Y chromosome. You don't do it. Don't do it. Okay. Remember Queen Victoria? Remember how she had hemophilia? Well, no, I talked to you about the Romanovs. Sorry. So this is Alexei from Nicholas and the Romanovs, and they were all killed. Anastasia's like one of these guys over here. Well, it originated from this lady named Queen Victoria, and she had a butt ton of kids. And because you want to share all the royal blood, they all married into royal families. So hemophilia is often called the royal disease because now all the royal families, at least back in the 1800s, had this disease. Notice, only males have the disease. It would not be against the rules to have a female with it, but again, it's more rare. In this case, doesn't happen. Also, look at the carriers, which looks like this. Do you see any square carriers? Do you? Do you? I don't think so. So, autosomal recessive. Key points. Both men and women are carriers, and both males and females are affected. Key points for sex-linked. Mostly males are affected, and only females are carriers. You're now going to do a butt ton of practice. Let me know if you have any questions. I'm also going to post a video for how exactly to determine whether or not how it's inherited, so be sure to check it out.